Doctors use CT scanners to take a look at what's going on inside of their patients without having to cut anyone open. Energy researchers use CT scanners to take a look at different types of rock while they investigate how they can efficiently access oil and gas. Dr. Dustin McIntyre explains.
My name is Dustin McIntyre. I'm a researcher at the National Energy Technology Laboratory.
Dustin started out his schooling much like all of you. He attended middle school and high school in Milton, West Virginia, before moving on to West Virginia University. A PhD in mechanical engineering led him into energy research. So this is Dustin, and this is Superman. What do they have in common? X-ray vision. Dustin finds his superpower in a lab.
One of the projects that I'm associated with, we use CT scanners to look inside of rocks. We have special core holders that we use to give the rocks the pressure and the temperature that they would see in the subsurface.
This is a core holder, and this is a core sample. A core sample is a section of the rock that operators drill through to reach oil and gas reservoirs.
And then we flow different fluids, whether they be oil, water, CO2, carbonated brine, to study the effects of some of the subsurface activities that go on in the real world. What happens when you take gas out of a rock? What happens when you take oil out? What happens when you put wastewater into? What happens when you put CO2 into a rock? So this allows us to see what's going on inside the rocks without having to cut them apart.
Okay, so to get oil and gas from shale formations like the Marcellus, engineers use hydraulic fracturing or fracking. The fractures or cracks created during this process provide a pathway for fluids like natural gas to flow through. How easily the fluids flow through determines how much natural gas can be extracted and how easy it is to extract. Temperature, pressure, geology, and chemistry are just some of the factors that affect fluid flow. If we better understand how fracture networks work, we can more efficiently access our nation's fossil energy resources to fuel our homes, schools, businesses, vehicles, and much more.
We can take the computer-generated data from the CT scanners, and we can make 3D models of the rocks that are exactly the same geometry, and we can study different parameters. We can actually take the scan of a real rock and turn it into what's called a digital rock and essentially simulate more experiments than what we would be able to do with our real laboratory equipment.
Underground reservoirs have naturally held oil and gas for thousands of years. By reusing these reservoirs for storage, we can permanently contain compounds like wastewaters that could otherwise have a negative impact on the environment. But whenever we remove or add fluids underground, we also introduce changes to the pressures, chemistry, and much more. Sometimes this can be a good thing. For example, adding carbon dioxide to oil and gas reservoirs increases the pressure and helps push out more oil and gas. Researchers are investigating how and why these changes happen so we can improve the safety and effectiveness of how we obtain our fossil energy resources. Most of our energy comes from abundant, affordable fossil fuels. Using science, engineering, and a little bit of X-ray vision, the work of STEM superheroes like Dustin and other energy researchers is making sure we have the resources to power a nation and the technologies to use the resources efficiently. Energy research is one way to make a difference through STEM. So now, what will you do?